Hello everyone. Today in this video I'm gonna showcase this Cocona CLI, which is a C# package that allows us to create the CLI scripts. What is cool about this project is that you can essentially use C# the same way as you do when you write any other, for example, web API. So what you're gonna be able to do is to feel exactly the same way as you do when you write a .NET project in the web API mode. I'm saying web API mode because it allows you to use all of the features that you have in C# with release. Now, let's start immediately on this project. So the first thing we want to do, we want to run the .NET new command. So .NET new console app, and inside this folder we're going to create this new console application. And then the next thing to do, it is going to install Cocona through of course we're going to use the CLI, so it's going to be .NET add package Cocona. Okay, so let's start by creating our first application. So we do using Cocona. And now we can do if you're using like .NET 6 and above, you can just avoid doing all the program CS standard, especially if your app is simple. So we're gonna make a simple hello world. So we're gonna do Cocona app.run, and here we're gonna say string name, and then inside we are going to put something like console.writeLine, and we're gonna say hello name. Alright, so we have our Cocona.cs, and what we can do now, .NET run, and we're gonna see the hello world. Now, as you can see, we have an option, name is required. So what we can do, we can actually run the help command, and it's gonna give us the usage. So usage Cocona CLI, which is the name of the package. So actually if we open this one, we can see the namespace is Cocona CLI, and the project is also called Cocona CLI. Yeah, you can modify those things. So like if I add a version, .NET run -- version, we're gonna see a random version, Cocona CLI 1.0.0, but what you can do, you can say version, and here we can say 1.2.133, and now we run it once more, and it should be Cocona CLI 1.3.3. So that's how you can change the version of your program. However, all of this output is automatic, and there is also some validation that happens. So now let's run it, .NET run -- and our option is called name -- we say Sam, and I forgot to wrap this. Let's try this again. So we run the command .NET run name Sam, and there you go. We have Sam. How about let's have a look at something a little bit more complicated. So what we can do, we can now come back to, instead of using the minimal API style, maybe we want to do a simple program, class program style, which works in every version, and maybe it's the one you're the most accustomed with. Alright, so I created a simple program class. We have a main, the regular main, which takes the arguments, and then passes those arguments to Cocona.run. And inside our program there is this hello command, and as you can see, there are some annotations. We have a command here with a description, add a .NET CLI program, and now we have this method with just some option. This means that it's an optional argument, so it's like a --u or a --use-joy, and we have a description. Now I wasn't sure what to do. I basically made it so that if you give this option, it's gonna print the user with an exclamation mark at the end. So let's have a look at what happens when we run this command. So .NET run --help, so we can actually see what Cocona expects us to pass through. So as you can see, we have Cocona CLI. The first option is --use-joy, and then finally we have the user. And as you can see, it took the name that we use for the variable use-joy to create the option, and u, which is the option short name that we have in here. So we can actually now run it, .NET run -- because we're not actually compiling it, so we just use it as a development. We want to do -u, and finally the last argument is the name of the user. We're gonna say Sam once more. And we get the hello Sam. Alright, so let's move on to the next command. We're gonna use the same structure, however we're gonna use sub commands, exactly like the first example I made. Alright, so now what we're gonna see, it's another feature of Cocona in which we can use subcommands. Now, I know this is a lot of code what I brought in here, however, I didn't want to bore you by going line by line and trying to figure out what to call the commands, etc. So, let's get started with what I brought in here. So first of all, we still have the command exactly the same way as we had before, except for the fact that now I added the enable shell completion support. This is an option that basically, as the name implies, it essentially, once we build it and we have it available on the path, we run the command. In this case, once built, will be called Cocona CLI. We are gonna be able to do something like Cocona CLI, and then with the --tab, and we're gonna give us the options. Alright, so let's try to run this command, and I will start by doing .NET run --help. Oh, sorry, this is the wrong command, my bad. --help, and what we're gonna see, we have the command hello, bye, and then we have nested commands. Where do these commands come from? So let's have a look. The first one, hello, is defined in here, and as you can see, it has this annotation with a command and a description, which is something we already saw. And now we have options and arguments like before. It's pretty much the same function as before. The only difference that the use-joy is determined to basically uppercase the name of the user, but the exclamation mark is given to every user we have. And then we have an argument with a description of username, and we use it, so the usage will be hello, optionally -u or --use-joy, and then we need an argument which is not optional, which is the username, and this --name, because this is what it's gonna take. Then we have another command which description is sayonara, and basically it's gonna try to greet the user in Japanese optionally. So we have this option J, so we can do, and that's a first level command. And then we have nested commands. Okay, so this annotation on this class, nested commands, let's put it on screen, of type of more nest commands, which is another class. So what is one? We are basically saying the first class has a commands, alright, and what I say is Docker style subcommands. So the main program does already have subcommands available here. So what this means, it means that I can run those commands which are defined in this class, nested commands. Now, nested commands is defined in here. However, I can define another set of nested comments for this class as well. And you can go on and so forth, but this is just for the purpose of a demo. Regularly, you do 2-3 levels of indirection and then you finish. So we have more nested comments, which means that when I run nested comments, I can have another set of comments which are, for example, bar, buzz, and the default command which is I run by default. So let's have a look at what happens when I run .NET run. We can run by, and then we can run the help, and it's gonna give us the option we have just seen. So we can do by -j, and our name, we still use Sam for our example. We should get the encoding correctly set in Japanese, and now we can go for the next set of commands, nested commands. We're gonna do this. I'm gonna run the help command to see what's available. .NET run -- nested commands. And now we have extra commands, which are get here, which is a first level command, generic greet, okay, here, and then I have more nest commands. So when I do Cocona CLI nested commands, and then I give it more nests commands, help, we're gonna have 2 more methods, bar and buzz, plus a default one. So if I go here and I define nothing, I am going to run the default command to be run, this one here, which is defined through this primary command. Let's give it a try. Default command to be run. Or we can run more nest commands, and then we can run ba or buzz, and so on and so forth. You can keep actually going, nesting and nesting and nesting, but of course at some point maybe loses usefulness. Alright, the next bit that we're gonna see is essentially using a minimal style API. We're gonna see how to write those commands, those nested commands, but just one level. Actually, I just realized that I've just shown how to do it. So what I'm gonna do now, I'm gonna show how to run the validation. So we're gonna say we have class program, and then we're gonna have static void main string args, and then we're gonna have Cocona app dot run program, and we provide the args as argument. The next one we're gonna have run, so public void run, and here we're gonna put some parameters that we want to validate. So let's say we have an age, we can use range, and now this is gonna be able this allows us to say, for example, when it's only people from 18 to 99 years of age, and we say age. We need to specify, alright, int age, and now we can say console dot write line your age you were born in 2024 minus age. Of course, this would work even if So we need data annotations. What is it not happy about? So here we need string, right? And then what is it not happy about here? Program. Okay, so what I'm doing wrong is actually I have this int age inside the square brackets, which is not where it's supposed to be. So this one is gonna offer validation. So let's have a look at .NET run -- help. And Cocona is gonna tell us the age. So -- age, and we're gonna say 3. And now Cocona is going to say that the field age must be between 18 and 99, which is kind of cool. Now, what I'm going to show you something that I find pretty cool. This is some more advanced validation and applies in general in your .NET projects. So we have an argument, and then the argument can be a string, and let's use the usual name. Now we say console.writeLine, and we say name without doing anything complicated. Now let's say I want to do something specific about this name. What I can do, I can add my custom validation attribute. So I can say class my custom validation, which is a validation attribute, and in here I'm gonna add a method which is standard, which is protected override validation result is valid, which is going to be called, and this method is going to get an object value validation context validation context. Of course, spelling the things correctly helps. Alright, so here we're gonna say we're gonna put our validation. So what do we want to do in here? We're gonna say that if value, which is the value of the string, name, and then name dot to lower invariant, because we're inside a method, is different than, let's say, reserved, and then not name dot contains not, we're gonna return validation result dot success. Otherwise, return new validation result saying that we can make a custom exception where we say that the name is not valid. Because here I need to use value, not name. Alright, so now what I can actually do, I can go here and apply this extra decoration, which is my custom validation. And alright, so let's have a look. Let's do the .NET run help, and we're gonna see that we have an extra parameter, which is name, which is required. So now if we run .NET run, and we're gonna specify age, now we're gonna pass validation, we're gonna put 98, yeah, and now we're gonna put the value of our name. We're gonna say something reserved. The name reserved is not valid. Let's say with something that contains not. For example, this is not a good value. The name, this is not good value, is not valid. But if we pass something, we can remove the word not and say this is a good value. We are born in 1926, this is a good value. And we have seen how to do validation, which is pretty simple. Alright, so now what we can have a look at is something a little bit more advanced, which is dependency injection. So we are gonna do, let's get rid of this, and let's get rid of this, and we're gonna run this program. Now we need to do some modification. So we have the class program, and now we wanna use some class to be dependency injected. So we have public program, and then we're gonna inject an iLogger program logger, and now we say logger dot log information, we need to, I suppose we need to import Microsoft extensions logging. We don't need any more the data annotations, by the way, we use them. So now we are injecting in an iLogger. So the next bit in this main is that we need to create a host builder. So Coconut app.run will be called later, because first we want to run create host builder, and now we say configure. This is exactly like when you do .NET services for web APIs. Now we say logging, and now we say logging dot add debug, configure services, and services yeah, here we can do services dot add transient, and here we can say my custom service, my custom service, and now I haven't defined this in my in my class, so class. So we do an interface, my custom service, public name, public string, get name, class my custom service, my custom service, and now we do public string get name, return Sam. Service collection does not contain a definition for add transient. Are you sure? Services dot add transient. Alright, because I need to inject dependency injection. Alright, so now I believe we have everything. I believe we have everything except for the app itself, the run itself that we want to actually do. I think it's gonna .NET run -- help. I think it's gonna run nothing because we need to have a method to run something. Yeah, of course, because cannot instantiate implementation type. So why am I getting this error? Alright, so the issue I'm having is that here I add transient with an interface, but I don't specify which class I want to use. And I should have my custom service. So I do the my custom service. That's because when I work, usually we have things like autofuck, etc. that basically they're gonna take care of taking the right classes and inject them. So you never actually you never have like really two implementations for the same interface in most projects. Alright, so the command not yet implemented. So Cocona is warning us that we have to do something about this. So we wanna add public void my command. And now what do we want to do? We want to use this service inside here, right? So we want to use this service. Let's change this one so that console.writeLane hello from my service. So our command here, we want to inject our service, and the service is called my custom service. So we inject it here, and we use the special annotation which is from service. And now here we specify my custom service, and now we implement my custom service dot get name var service name is equal to this, And now we're gonna do another console.writeLane. The service returned service name. And now if we run this again, everything should work correctly. And yes, we can actually run it on net run. This time no arguments. Object reference do not set to an instance. Is this why? Okay, why is it complaining? Okay, so the other problem I'm having is that I'm an idiot today, and here I'm injecting the implementation, not the interface. This one should actually be the interface, and then dependency injection is going to take care of what I need. So if we do .NET run, alright, so we get instance of the program created, hello from a service, the service returned Sam, which is the value I was returning as a string in here. And this is dependency injection. So I have one more example to provide, and the new example, I'm going to create a new file, app settings. Well, actually I want to create it app settings.json. Let's open the file, and here we're gonna say configuration my value is 1, 2, 3, 4. It's just a string, and here we're gonna find a couple of modifications to this program so that we can read this configuration. So we have a private string, my custom value, and inside the program we add I configuration. Okay, so add the dependency, and now here we say that my custom value is equal to configuration dot get value string, and we need to specify, I called it configuration, configuration. And now this I return the service name, console.writeLine. This is coming from the configuration, and the variable was called, I already forgot, my custom value. Alright, let's try it once more, and we should see this is coming from the configuration. My custom value did not work. So what am I missing here? Let's have a look. Alright, so after looking at what could possibly be wrong, variable names, etc., I've actually noticed that I called the file app setting rather than app settings. Okay, so let's just rename the file appsettings.json, and let's run .NET once more. And as you can see, I can read the value. And now if you specify environment variables, etc., and you have, for example, if when you run the command line, you say .NET environment is equal to development. Okay, so let's new file appsettings.development.json. Actually, let's open up my dev is 1, 2, 3, 4. I went to the wrong place. Okay, program.cs. Now I set my .NET environment to development, so when I now run the command line, we are gonna see that is actually going to get so actually we want to do export, and today I'm missing all the letters. .NET environment, .NET run, and we need to add services. Alright, so we are getting this my custom service from root provider, and the reason should be that the my custom service is registered as a scoped service, but this is not what should be happening. This is actually a singleton essentially. So add singleton, and yes, everything is working fine. My configuration, my value is 1, 2, 3, 4, but now I want to say also export .NET environment equal to development, and then we do .NET run, and it's not being picked. Okay, let's run it in the same line. Export Alright, it's not getting my configuration for some reason. Alright, why is that? Alright, so the error I made is that I call this one upsetting once more rather than upsettings. But other than that, everything is fine. Well, I hope you guys enjoyed this demo, and if you have any questions, comments, please leave a comment below. And if you use any other tool for writing your command line app, I really want to know, so please leave a comment and let me know which one are your favorite tools to write CLI tools in .NET. Thank you very much, and see you in the next time. Bye bye.